Hello! So in this tutorial we'll go over how to render a triangle with OpenGL and, well, everything to do with that. So essentially we have to load all the specific data into a Vertex buffer object, which is put into a Vertex array object, which is then rendered to the screen, which is called a frame buffer, which is then put onto the window that we have. Now, I need to fix a few things from the last tutorial, as I was nicely informed by someone in the comments from my previous video. The window hints need to be created, or need to be set before the creation of the window, so just move that back up there. Right, so the first thing we're going to do today is we're going to abstract all this window stuff into a new class to keep the main class all nice and tidy. Let's go to source, add new item, then go C++ class, DisplayManager or something like that, whatever, it doesn't really matter. Right, so the first thing that we're going to do is we're going to have a, header guard. This essentially stops files from including the same header twice and causing linker errors. We do if not defined. Let's give it a name, I don't know, or let's just call it DisplayManager, because that makes sense, _h. Then we define DisplayManager. They have to be the same, these two pieces of text right here. Then we define the entire file as DisplayManager.h. So what we're going to do is we're going to include glfw, because we're going to need that. Initialize function, which we will put into the DisplayManager.cpp. Oh yeah, that's something that really annoys me about Visual Studio, that when you create a class you can give it a base folder. I mean, I may not have actually done it this time, but even if you can give it a base folder, it doesn't actually put it in that folder that you set it to be in. Just go and take that, put that in here. Don't forget to include IOStream if you're using cout. Otherwise return 0. So, in here we'll create a new DisplayManager object, let's call it DM. Actually no, might as well call it something a bit more descriptive, shouldn't I? Let's just call it DisplayManager. Let's just call it that. So if not if DisplayManager is equal to -1, but no, DisplayManager.init equal to -1, then we return -1. Might want to tidy that up into one line. So now we do a create window class. Oh, I misspelled create, wow. Just gonna do a nice old copy and paste of all of that. We're going to call it from here. Right, and all of that should be absolutely fine. That will have to remain as it is in here, unless I want to create a new function in here, but it's literally just one line that I don't think really matters too much. And actually, that, you know what, actually no, so let's just go and copy and paste all of this into a new file. not new file, you know what I mean, new function, let's call it setup context. Shove all that code in there. Right, and we're going to need to copy and paste this back into here. But don't put it in the header file, because it has to remain like a C-like function. And yeah. Right, so if we do right, got to yeah, no, that's all good. Yeah, cool. Right. So now we've abstracted all of that. We should be able to get into the well, what's actually meant to be happening in this episode. So I'm just going to pull up Paint, because why not? Yep, and I'm going to explain VBOs. Essentially, you can think of VBOs as sort of, I don't know, trays or drawers in a cupboard. Well, okay, say you've got a cupboard like this. Excuse my let's pretend that's a drawer. Okay, again, that makes it look worse. So this nice old cabinet here is a VAO, Vertex Array Object. Now each drawer here is called a VBO. Now this VBO can contain data such as VBO can contain positions. A VBO can contain positions, color data, texture coordinates, or it can, well, for each vertex that is, and they can contain normals. Another type of buffer object you can have, these are called these are called array buffers. Another one you can have is, let's say, an IBO, an index buffer object, which contains the indices in which order they should be rasterized in OpenGL. Right, so now that I've kind of explained that with my massively impressive paint skills, and smell sarcasm there, let's actually put this into code. So, what we're going to start off with is just simply the vertices of the triangle. So these are the positions of the coordinates. It's 3D coordinates because OpenGL is a 3D API. So we can use negative 0.5, negative 0.5, 0. The final of these three is x, y, z. Z is how far, what's the depth. And because we currently haven't got depth set up, and perspective, well, if we made this go any further, if we made it more than 0 or less than 0, it'd either be in front or behind the actual camera itself. So essentially what happens with OpenGL the center of the screen is 0, 0. To the right, over here, is x plus 1. To the left over here is x minus 1. Down here is y minus 1. Up here is y1. So this, negative 0.5, negative 0.5, is about here. This here, 0.5, negative 0.5 is about here. And then this, 0, right in the centre, 0.5 is about here. So, to actually get this to the screen, we're going to need to, first off, well, we're going to need to create an ID variable for our VBO. This is of type unsigned int. Let's call it, well, VBO ID or something like that. Doesn't really matter. And now we have to create the buffers with OpenGL. GL gen buffers. Now asterisks. 1, that's how many we want to create, and we pass in the VBO ID by reference. Now, as we have to do in OpenGL, we have to bind something before we actually do anything to it, like create data with it or whatever. So, GL bind buffer, GL type array butter. Did I just say butter? Okay. GL array buffer, then passing VBO ID, not by reference this time. So, a rather simple or simply named function is GL buffer data. I can actually type GL buffer data. We type in the type of array, which is GL array buffer, and then the size in bytes of the data we're about to put in. So we just put in the size of vertices, then the actual data we want to put in, and then what we want to use it for, which is GL static draw, so we're not going to be changing it. We're going to need to create a vertex shader. This is the shader that performs calculations on the GPU about the positions, well, it does stuff to do with the vertexes, or vertices of an object. The next one is a fragment shader, which does all like the graphical stuff like colours and stuff of the fragment. It's probably a bad way of explaining it, because C++ file system is kind of slow. We're going to just define it as a string. Let's say vertex source. So this language is called GLSL. So what you want to do first is declare the version you're going to be using. We're going to be using version 3.0, which is defined as 330, with the core profile. Now we just make sure that a new line is created, otherwise GLSL will have a syntax error aneurysm of sorts. Anyway, so first thing we need to do is take in variables from our VBOs. So let's say, well, we have to declare what location in vertex attributes the variable is. It's an input variable, and it's of type vector3f. So, yeah, x, y, z values. Let's call it position. Don't forget semicolon and new line. So we create the main function. And we declare the final variable, which is the OpenGL output variable. That simply, well, defines the position of the vertex. Equals, it's a 4D vector, and there's some drive. This should technically work, right? But for some people, like I tested a program on my friend's computer, and it didn't run. Then I changed this to put in every single element. It did work, so just to be safe. Right, and then we null terminate the string, just to make sure we don't get string garbage whenever we load it in, and then we get errors. So after the VBO is all done, or set up rather, we should create an ID for our Vertex shader. Let's call this VS ID, Vertex shader ID. VS equals GL create shader, type GL Vertex shader. Although it shouldn't be called VS, it should be called VS ID. And then we put in the source code, so GL shader source, VS ID. And then we pass in by reference so we pass in the source by reference, we just into null, and then we compile the shader. Now this should effectively be it for shaders, but if you were to get an error, your program would just fail to run, or something would go weirdly, and so therefore, well, you don't know what the problem is, and so what we need to do is, well, be able to get the error message from GLSL compilation. So we define a variable to check if it's a success or not, and we create the buffer to put the error message in, and we get GL get shader IV, the ID of the shader, the compile status of the shader, and whether or not it was a success will be put into the variable of success. So now we check if it was not a success, and we get GL get shader info log, pass in the ID, pass in the buffer size, same as that, null and info log. Then we might want to print out something like failed to compile Vertex shader, reason, then we input the info log. That will print out failed to compile Vertex shader, reason, and then the error message in here. Now we do the exact same thing with all of this, just copy and paste, but change the variable FSID instead of VSID, because we're going to be doing Vertex. We're going to be doing the Fragment shader now, not the Vertex. We can use the same variables, well, same variable for success. Just make sure to keep passing in and change that to Fragment shader. Make sure here you don't set it to GL Vertex shader, you set it to GL Fragment shader. And we're going to create a new variable called Fragment source. Just like the Vertex shader, we've set the version. Then we declare our input and output variables. So for the Fragment shader, our output variable, let's call it color. And then we create our main function. Then we do color equals 4D vector, because it has to be a 4D vector, the output variable. I don't know, let's say, you know what, let's do some fun, let's just to learn. So let's declare an output vector 3 current position, and then we declare here current position equals GL position. Wait, no, we can't do that. Just call it position. It needs to be the same as that one. And here we just created an output variable which we can take in with our fragment shader here. In VAC3, make sure to give it the exact same name, copy and paste if you want to be safe. Then we can do pos.x plus 0.5 .x, not .z, just to make sure we don't get any like just pitch black. Current position .y plus 0.5, current position .z plus 1.0, and then just 1 point. Don't forget to have the curly brace in the end and the null termination. Right. So now we need to actually define a shader program. So let's give it an ID here. Unsigned integer shader prog equals GL create program GL attach shader program and the Vertex shader ID. Then we do the exact same thing with the Fragment shader ID. I'm going to rename these variables to be a little more easy to understand. So we attach them, and we link the program. Don't know how that happened. Just going to type on keyboard shader prog. And now we have linked the shader program, and it should effectively work in terms of linking and everything. But again, we want to do a similar thing to this. So we use the same success variable. You didn't need to have the success here, just remove that. So we'll do GL get program IV shader program GL link status and put it, and the result will be put into there. If not a success, then we get GL get program info log shader program 512 null info log. Then we'll want to print it out to the console. Now, before we actually do anything with the shader program, in terms of interfacing with the shaders and everything, we need to bind it, and to do that we'll use GL-use program. In fact, I'm going to go around here and I'm going to rename these things. Infolog fs. So we don't get any weird artifacts. And we'll get in here. So after binding or using the shader program, we'll delete shaders. It just frees up some memory. GL delete shader, fragment, shader ID. This isn't done yet, all of this, because we actually need to link the vertex attributes. We need to call the function GL vertex attrib pointer. We're going to use 0 because that's the location we set here. Oh, syntax error. Location equals 0. Don't forget to change that in yours if you copied me. 0. There's 3 values for vertex, so 3. The type is float, so GL float. You don't want to normalize it, so GL false. The size of each vertex, what's the size in bytes, is the size of float times 3. So we'll do 3 times size of float. And then the offset between each one, the space in between each one, which is 0. Now we have to cast that to a void pointer, and I don't know why. Now we need to enable that vertex array. Right, so now we need to create the VAO. So, we create another ID here, unsigned integer ID, GL generate vertex arrays, one of them, and pass in the VAO ID by reference. Now we need to bind the vertex array. It's just pass in the ID, and do all of that actually before the VBO is created. Right, now in our render loop, say here render, we need to bind the shader program. We need to bind the VAO. And then we need to call GL draw arrays. Now we want to draw it in triangles, not lines or vertices. And there are 3 vertices. Now this should work. Nope, it doesn't. Yep. That's why we need to include glad before we include glfw, which is included in this header. Put glad up there. Well, it fails to initialize glad in glfw, so that's nice. Oh, that's one thing. We failed to check if the window is equal to null. That should stop the glad error, because that was being thrown, because it was the context was being set to a null window. I guess this could be a reason we were setting this version here to this glfw context version. That should work now. And when you look at that, we have our rather nice looking triangle here, because we haven't set up perspective. Well, it resizes depending on how big the window is, but you know, we'll get to that later on when we actually transfer to 3D. So yeah, thanks for watching.